Okay, in this video we're going to talk about the different patterns of acid-base reaction. There are basically two reaction types, but one of those types is going to be broken up into like 5 different patterns. So I do apologize, this video is going to be on the longer side, and there aren't really going to be a lot of worked examples because again we're going to save a lot of those for when we get into class. But let's start off with our first type. This first type right here is called neutralization. A neutralization reaction is when you take any acid and react it with any base that's formed from a hydroxide. Doesn't matter what hydroxide it is. It will form a compound called a salt, which is just an ionic compound. Right? So any ionic compound is known as a salt, and it will also form water. Right? So hydrochloric acid and sodium hydroxide forming sodium chloride and water is a neutralization reaction, as is hydrobromic acid reacting with barium hydroxide to form barium bromide and water. Now, for this particular type of reaction, the net ionic equation will depend on how strong the acid and the base are and whether or not the salts are soluble. Right, so there's a lot of things you have to keep in mind when you're writing this. So like this one right here, strong acid plus strong base, strong acid plus weaker base. All right, so this is where we're going to get our patterns from. Whether or not the acid is strong, the base is strong, and how soluble the salts are going to be. All right, so this will be the next 5 slides. First slide's the easiest though, strong acid and strong base. Right, so this was our HCl plus NaOH reaction. The good thing about this is that for a strong acid or base, the acids and bases all completely dissociate into H plus and whatever the ion is, and whatever the metal is in OH minus. Now, since they all dissociate, this is essentially just a single replacement reaction. Now, if you notice, for all the strong acids and bases that I gave you, all group 1 compounds from the strong bases are completely soluble. For the acids, all of the ions I gave you from the acids will also be soluble because they're combining with a group 1 metal. Right? So salts are always soluble. So that means that our net ionic equation here is really easy. Formation of water. Right? The only substance in an acid-base reaction between strong acid and strong base that will not dissolve is the water. So this will always, always, always be the net ionic equation for a strong acid and a strong base, regardless of which acid or base it is. Right? So this is any strong acid or strong base, just immediately write water. Now we're going to start mixing these up a little bit. Right? So we'll mix it up. What we'll do is we'll change the base. So instead of having a strong base, we're going to go with a weak base. Now again, strong acids completely break up. Weak bases don't. So what that means is that they're going to be written in molecular form. Right? So weak base will be written in molecular form. You'll still probably put AQ after it because it will still be in solution, but it just doesn't break up. Now, when you have the salt that you formed from this reaction, the salt may or may not dissolve in water. Know your solubility rules. That will help you out. This is where I said, like, things kind of get a little bit weird. Right, so general form, if your salt will be soluble, and again, we're assuming on a hydroxide base here, is you're going to have the H plus from your strong acid reacting with the weak base. You'll form the conjugate acid, which is B plus, and then water. Right, so if the salt dissolves, that will be your general form. If the salt doesn't dissolve, then you have to write the negative ion, because what will wind up happening is that, remember, if the salt's not soluble, this right here will be solid. So you need that A somewhere, in this case right here. right? So if it is soluble, and again, the one thing I will just point out is that for the most part, we will still write AQ here for the base because it's in solution, unless we're specifically told otherwise. Like if they said we had solid base, then we'd write solid. Right, so this is a strong acid and a weak base. Now let's flip this around. Flipping it around is actually a little bit easier. Right, weak acid and strong base. So again, weak acids don't break up 100%, so we write them as molecules with the little AQ next to them. Strong bases always break up into ions. Now your salt that you form will always be soluble because the metal is always a group 1 metal, right? So we don't have to worry about solubility there. So what this will do is we'll have our weak acid, and again, even though it's probably in solution, it doesn't dissociate, so I'm just going to say AQ, plus hydroxide from our base. Remember, the metal is soluble, so we don't write the metal, yields the conjugate base plus water. Right, so this is weak acid and strong hydroxide base. That leaves us one more combination, right? We've done strong, strong, we've done strong, weak, we've done weak, strong. Now that leaves us with weak, weak. Neither the acid nor the base are soluble, so you're going to write them as molecules. Again, you're probably going to put AQ next to them, unless they tell you they're specifically solid. The salt that you formed might be soluble. It also might not be soluble. Right? That's one of those where you're going to have to know your solubility rules in order to determine it. So if the salt dissolves, then we're going to have our HA, which again, I'm going to assume is solution, so aqueous. Our weak base, which I'm also going to assume is aqueous. H plus and OH minus will form water. And then if the salt dissolves, B plus and A minus, because those are the two ions that make up our soluble salt. Just like we did when we wrote regular ionic equations, right? So this will be just a general ionic equation. If the salt doesn't dissolve, then good news. Just write the molecular equation. It'll be the same thing. Right? So if the salt is a solid, molecular equation for the reaction will be the actual answer. And this leads us to our second major classification of acid-base reaction. Don't worry, this one's actually really quick. It's just like one slide. Our second major classification is what we call proton transfer. So all of those last little subtypes are of neutralization. This is proton transfer. So neutralization is if the base is a hydroxide. Proton transfer is when it's not. Right, so a base that is not a hydroxide, you use this. These are really easy to do because it's acid plus base yields conjugate acid and conjugate base. Right, so all you do is you literally transport the hydrogen to one side. So as an example, hydrofluoric acid is a weak acid. Ammonia is a weak base. It's not a hydroxide. So what's going to happen is that this hydrogen right here, and you may have done some of this sophomore year, this hydrogen is going to find its way over to the nitrogen atom right here, forming NH4+. Then we're left with fluoride here because we took away the H plus from that. Right? So, and this reaction is reversible. This will be the proton transfer reaction whenever you don't have a hydroxide. So this one is really straightforward and simple to do. Right? I know that was a lot. I know that was actually quite brisk pace. Please be sure to bring in any questions that you may have, because I'm sure you probably have quite a few. And we are going to spend a lot of time going over how to write the different acid-base reactions. Alright, so I will see you guys next for the last video of this unit.